Okay, welcome to the course of Intelligent Healthcare and its applications. So let's continue on the workshop of this today's the course, which is the random forest decision model and its applications. Okay, so before we move on to the workshop, so let's take a brief review of the decision tree. And again, this is the general representation of the classification and regression tree. And the idea behind the decision tree is that we can use a bunch of the decision nodes that can create a flow chart that we can move from one node to the other and to decide whether or not it will result in one of the classification state or categories. So this is a very useful model and is very easy to understand because for this tree, then we can quickly understand what is the important factors that affect our decisions. So for example here, the overall question is that should I accept a new job offer? And it's very obvious that the most important predictor is that is the salary. So if the salary is not enough, then you just have we just decline the offer. Okay, so the tree is very useful. However, it has some limitations, and if we have a very complex data, then the tree probably will. Then we will probably have many ways to create such decision tree. So we need a method that to find the consensus between different tree representations. So one of the methods that we can use ensemble method, which we can generate the tree from many times and to find the majority of these tree structures and which result in a final random forest decisions. So it's just like a democratic system that we use the majority vote, or you can use the mean value of this tree. Then we can find a general representation of the decision tree. So that is a big improvement because not only we can have the reserve the interpretability by the decision tree, but also we will keep the variance low while maintaining a low bias. So in other words, we can maintain a high accuracy and a high precision. So that is the big idea behind the random forest decision tree. So today we will work on a very unique data set. The data set came from University of California, Irvine campus. So it's UCI. And they have a very famous archive of machine learning data or machine learning repository. So you can visit this website, which is archive.ics.uci.edu and machine learning ML. And they contains lots of machine learning data sets, so you can play with this data and to find out a particular application. So you can play with many methods. So these are very good resources that you can learn the machine learning. And so today there's a chronic kidney disease data set, and it is contributed by India doctors. Okay, so the data contains the 25 variables, including the classification of the chronic kidney disease. And also, there are 400 rows, means that there are 400 cases and included in this data set. I think it is a good example that we can practice the decision tree model using this data set. So, but what is chronic kidney disease? The chronic kidney disease is condition that results in manifest by a chronic deterioration of the liver and renal functions, kidney functions. So this may happen slowly over many years and can be differentiated in the different stages. And currently, the guidelines of the chronic kidney disease is that there are 5 stages and differentiate by the different conditions, which is defined by the glomerular filtration rate. So GFR stands for the glomerular filtration rate, which means that the ability of the kidney to get rid of the waste. So the function of the kidney is generally that to get off the waste from our body, but also at the meantime also keep the essential nutrients inside our body. So, for example, the proteins. Normally the proteins will keep inside our body because it's a very important nutrition that we need proteins and amino acids to build our the tissues and cells. And so normally the kidney will not get rid of the proteins into the urine, but in the case of the diseased kidney, which has the impaired renal functions, the proteins and other nutrients might just leak into the urine. So not only the ability of the filtration of the waste is impaired, but also it has the impaired ability to keep the essential nutrients inside our body. So in general, we can use the GFR as an indicator of the chronic kidney disease. So in the stage 1, which is still maintain a normal kidney functions, and you can see that even in the GFR around 80 to 89%, there is already the mild loss of the kidney functions. And in the final stage, there is a kidney failure, then the patient need to undergo dialysis. So this is the general representation of the chronic kidney disease. And there are many risk factors associated with the CKD or chronic kidney disease. For example, the diabetes and high blood pressure, and also the heart problems or stroke or obesity or family history or tobacco use or the old age. So these factors are non-predictors of the CKD. And I think most people know that in Taiwan, many patients suffer from the CKD and they require dialysis, for example, maybe 3 times per week. And so that is the very big problems. And so if we can develop an AI model that can predict the CKD, that would be of some use. So, but today, we will use this data set to build a simple model to differentiate patients with chronic kidney disease and those without. So if you download the full data set from the UCI machine learning repository, then when you open these CSV files, you should be able to see there are many variables included in this data. And so, for example, we can see there is a demographic profile such as age, and also like blood pressure, and also like blood urea level, and serum creatinine, and maybe blood sugar, and also other like white blood cell count or hemoglobin, and also the history of the hypertension or history of diabetes, etc. So there are many variables are here. And when you look at the website, you should be able to see the explanation of these variables. For example, there's abbreviation of the variable, and you should be able to understand what's the meaning behind these variables. Okay, so to simplify our workshop today, and also you should have already noticed that there are some missing values in these data sets. So because I think it's not our focus to teach how to deal with the missing values, although that is very important, but to simplify our workshop, I just want to give you a complete data set and also simplified. So I already pick up some important variables from this chronic kidney disease data set. And also I already delete those cases with missing values. So when you download the data from the campus video websites or my laboratory website, you should be able to see the full data, but with the fewer cases compared to the data downloaded directly from the UCI website. So in this simplified data, we have 368 cases, and there are 228 patients with chronic kidney disease, and also 140 patients without CKD conditions. Okay, so the variable included in this simplified data are age, and also the blood urea level, and serum creatinine, and also the history of hypertension, history of diabetes, and history of the coronary artery disease, and also the basic questions, the condition like whether or not this one has a good appetite or poor appetite, or the pedal edema, or like anemia history. So the final variable or final column in this data is the classifications. And CKD stands for the chronic kidney disease, and also there is a non-CKD classification. So it is a binary classification data, which means that we only need to decide whether this case is CKD or not CKD. So that is, I think, is quite simplified, and you can play with data without any extra work. Okay, so the first thing we need to do in MATLAB is to read the data into the table. So in the previous lectures and workshops, I show you that we can read the Excel file or CSV file using the XLSRead. And using the XLSRead, then we can import the Excel-like files into like numerical data or text data or raw data. However, for the machine learning, that you can see that it's better that we just input the data into the table format. So it's easier using the table format to do the regression and training with different kind of models. So this read table function can directly read the table information, including the name of the variable, into a data variable. So you can name this as a data or something else as you like, but the essential part here is that we use a read table to create a table variables that contains the 368 rows by 11 columns. So you can see that the final column is the classification of the patients, and the others are the variables. But also, please note that I delete ID in the data you downloaded from my library website, because this ID is not necessary in our prediction. So you should be able to see from age to anemia, which have 9 variables. We use these 9 variables to do the predictions. Okay, so after I read the data, then we can now use the simple classification tree model to do the training and the classifications. So we just use a function called the fit classification tree, which is the fit C tree functions to train the decision model. So here we just type the tree equals to fit C tree, and the input parameter include the data table we just imported from the CSV files, and also we need to specify the response variable as the classification. So remember, in this table we have a variable called classifications, which means it's a response variable divided into 2 categories. One is the CKD and the other is not CKD. So that's why I put the classification variable as a response variable. So when you execute this function, you should be able to see this result. And this result just show you the training and the characteristic of the model. So in this model, we include the predictors such as age, blood urea, and etc. There are 9 variables here. And response variable is the classifications. And also, there are categorical predictors, which is the hypertension, diabetes, coronary artery disease, appetite, pedal edema, and anemia. And the class names they already created for you is CKD and not CKD. Okay, so a number of observation is 368. So it just show you the basic characteristics of the model. Then you can simply type the view tree here because it's a simple classification tree. Then you will try to find out every possible way to fit the data. So naturally, if you just do the simple classification tree, it will result in many nodes because the model will try to round every possible branches to differentiate the CKD and those without CKD. So if you just type view tree in the MATLAB, you should be able to see the results of this tree, the classification results. So it's a decision tree for classification, and the first line says that if serum creatinine is smaller than 1.25, then node 2, else if serum creatinine is larger or equal to 1.25, then node 3, and else CKD, means that if serum creatinine is larger than 1.25, then it's chronic kidney disease. And it's very reasonable because in nephrology, the one critical predictors of chronic kidney disease, or one critical indicators of CKD, is the serum creatinine. So that is why we always use creatinine as the indicator. And of course, and if the creatinine is high, then it's a CKD. But when in the case of the normal CKD, normal serum creatinine, then we will further determine several conditions. And so there are lots of decision nodes here. So the second nodes here is the diabetes. If there's a diabetes, then it's CKD. If not, it's not. So you can read these text report and to understand the logic behind the decision tree. However, you may ask, this is not very straightforward, and so how about we just create a tree graph? So it's not difficult. So again, you can just type into the view tree, but you add a parameter which is mode graph. So it will plot a graph for you. So using this graph is more simple to interpret the model. So for the first decision node, then you will see that the most important predictor is the serum creatinine. Okay, if this SC is larger or equal to 1.25, then it's a CKD. And if the value is smaller than 1.25, then we need to determine if the patient has a diabetes. If it's yes, then it's likely that patient has a CKD. And also, interestingly, you can see that the third nodes here, we need to look at the age. If the patient has no diabetes, but the patient's age is younger than the 11.5 years old, then it's classified as CKD. This is not very reasonable, but it may be just because our data has only around 400 cases. So you might encounter some the strange predictors. And so that is, again, this is one of the limitations of the decision tree, because sometimes it will result in a classification not, you just feel that it's not very meaningful in the clinical practice. Okay. So for the others, for example, here, if you have edema, then it's likely it has a CKD. Anemia history, yes, is a predictor of the CKD. Also the poor appetite, also the blood urea levels, and also this. Again, this is a very complex decision nodes here. So you can see that this is not a very perfect tree, but the model just try to use every possible decision nodes to differentiate the CKD and non-CKD. So our next job is to try to optimize this model. And the first thing we need to do is the validation. So for the simple commands we use here, we just feed a simple decision tree, but there's no validation for this model. So for the validation, the commonly used technique is the cross-validation here. So use the same command, the fit C tree, then we can add a command that is a parameter is the cross-validation on, means that we will turn on the cross-validation feature in this tree model. And also, we don't want so many decision points, because if you want the model to be very practical in the clinical practice, you should make the model as simple as possible. For example, in this pandemic of the COVID-19, imagine that you are the emergency doctors, then when the patients come in, you really want a simple flow chart to determine whether or not the patient may have the COVID-19 infection. For example, the fever is one feature, and also the cough with the difficulty breathing is maybe another feature indicating of the presence of pneumonia. And maybe another feature like diarrhea, which is a typical feature of the viral infections, and also maybe a loss of the smell and the functions. So that is, we really want the simple questions. So that's why we can limit the number of the decision nodes here. So here we just limit to the 5. So it means that we only need 5 decision nodes. Then when you train this tree, then you can view the results using this graph. And remember that in the previous, the simple model, we just simply type the view tree. But here, because we turn on the cross-validations, and there are many training results, so we typically just view the first set of the trend result here. So we'll type the tree.trend and the first set, and you still visualize the result using the parameter mode graph. Okay, so for these results, we can see that the single most important predictor is still the serum creatinine. So here the creatinine level is, the condition is the same as the previous tree, and also we found that diabetes and ages and the edema and the appetite is the important factors to differentiate the patient with CKD and those without. Okay, so this is the validation part, and also you can type the tree.k-fold loss to see to evaluate the model. So here we can see that it means the classification errors, and so you can see that the error is quite low in this case. So it means that we can just use a simple decision tree to result in a very high accuracy of predictions. Okay, so now if you remember that these, even we do the cross-validation, is not enough because the tree may have a different representations, and each time you run the classification, you may be able to find a different representation of trees. So it's very important that if we can incorporate a large number of ensembles of trees and to find the consensus of the final results. And that is the concept of the random forest decision tree. And to do this, we can use the fit classification ensemble function, which is the fit C ensemble functions here. Then we can input, you still use the data as the input and the classification label as the output. And to differentiate, to distinguish this model from the previous one, then we designate this tree as the random forest tree, RF tree here. So if you run this command, you should be able to see these results. And the difference between these results and the simple decision tree is that you can see that we have number of the trend here, which has 100 training of this model. Then each time of training, then will result in different representations, but we will find the consensus of these 100 trees. Okay, so to visualize this tree, we can still use the view RF tree, and then there's the subparameter is called the compact regression learner. Then you can visualize this set of the tree. You can see that it's still a little bit more complicated than the previous one. So the random forest tree, although it has a consensus, it will try to reach the most accurate or most consensus tree in the random forest, but still it can have a very complicated level of decisions. But you can see that for those first few levels, the result is still consistent. So these important predictors, including the serum creatinine, the history of diabetes, the age, and also the condition of the edema, and also the history of anemia or appetite. So I think these are important predictors, and it's very consistent with clinical insights. So if you are doctors, then you should keep in mind that when you you suspect a patient, if he or she may have a CKD, you should ask these questions, whether or not he has a diabetes, or you should check the pedal edema. You should check if you have an anemia history. You should ask if he has poor appetite, and you should do some laboratory tests to see if they have an elevated serum creatinine level. So I think that is the beauty of the machine learning, because the machine learning, the most important things about machine learning is that we need to know why. So the explainability of the model is very important. We need this explainability to develop the clinical insights. Okay, so how about this is a very simple workshop. Then we have a very simple data. So now you might wonder that what is the accuracy and what is the ROC curve using this kind of model. So to simplify the course, I will show you how to run this in a MATLAB app, which is the classification learner. So I encourage you to practice on writing just few lines of code to build a decision tree model. But if you want to see the training results and also validations using a very simple user interface, I will show you how to do this in the MATLAB app. So I will just pause this presentation and continue use EverCam to record the steps I use in the MATLAB. Okay. Okay. So when you open the MATLAB, you should be able to see this kind of the user interface. So remember that in the left side we have a current folder, which is now my teaching course folder, and also contains the data I gave you in each workshop. And then in the central, which is command window, and you can type the simple command, or you can write some simple script here. And in the right side, there's a workspace which include the variables or answers that results from the command window. And in the right side, there's a command history. So you can see that I already do some the decision tree models here. So you can just look into the history of command and try to keep, and those are useful commands. Okay, so the first thing is that we need to import the data. So remember that we can use the read table to import the CKD subset.csv. And when you do this, you should be able to, there's a data which contains the 368 rows by 10 columns. If you double click on the data, you can see there's the variables age, blood urea level, serum creatinine, and also the hypertension, diabetes, coronary disease, appetite, edema, anemia. And the final column is the classification. Okay, so as I said, we can just simply use the app here. So you just click on the app and click on the classification learner. Okay, so you can see there's a user interface pop up, and we simply click on the new session. Okay, then we can see there is a data variable in the workspace, and we need to specify the response. So the response is not hypertension. We should specify response using the classification variable. So there's two unique categories in this variable. And MATLAB, this interface is very friendly. So if you have more than one class, you will automatically detect the class labels for you. Okay? So in the right side, we need to specify the number of the cross validations. So by default, it has 5 folds. Means that the meaning of the cross validation is that you will keep one part of the data as the training and to use the other part of the testing, just like what we did in the regression training. But here, the cross validation can just do this validation automatically for you. So maybe you can use the 10 folds of validations. Then we can start the session. Or you can also use the no validation, but I will suggest that you will use the cross validations. Okay. So after you click the start session, you should be able to see this the basic the graph. You will try to plot the relationship between two figures. You can change this by, for example, we want to see the relationship between the age and the serum creatinine, or it will show you it's a CKD or not CKD. So if you have predictors that is very significant to classify this class, then you should be able to see the results or visualize the difference in this scatter plot. Okay, so I would suggest you to uncheck this use parallel functions. It means that the MATLAB will use the multiple process in your CPU to accelerate the training process. But because the model we used are quite simple, so you don't need the parallel functions. And so I would suggest you to uncheck this one so you can decrease the running times using this very simple model. So when you look at this, we'll click on this button, then you should be able to see there are different model of decision tree, and to put it very simple, just is there a fine tree, means that you can just create a very detailed decision tree for you. And there are lots of decision nodes, and there's a median tree. You can maybe just there's a explanation here is a decision tree of median flexibility with fewer leaves. Maximum number of the nodes is 20, and there's a coarse tree which is limit the number of the splits to be 4, which means that you have only 4 decision nodes. And you can also run all types of trees here. So, and also you can do the ensemble classifiers here. For example, the boosted trees, the backlit trees, they are all though one of the kinds of the random forest decision models. And you can also look at the all ensembles here. So how about that we just do the decision trees first? So we can just click on all trees and run the trend. Okay, so you just quickly run the tree for you. You can see that for the simple tree, we already achieved the highest accuracy around 95.9%. So it's a quite good result. And if you click on the ROC curve for this model, you can see that the area on the curve is high, and So it's AUC is 0.96. So that is a good result. Okay, and from the lower left corner, you should be able to see the training result here. Then you can see the accuracy, you can see the max number of split, and you can see the feature selections. And here, then we use the PCA, Principal Component Analysis, but we disable these feature selection options. So if you want to see the results or export the model, you can just simply click on the export the model. Then you can plot the tree in the MATLAB using the command I showed you before. So I will leave this for you to do some homework. And also, let's work on the ensemble classifier. So just click on the all ensemble. We just try everything. Okay. So click on the trend. It will run a boosted trees for you and back tree for you, and also the RUS boosted trees. Okay, so you see that, okay, the highest one here is 96.5. So MATLAB will automatically select the model with the highest accuracy for you. So for this one is the backlit tree. Then you can look at the information here. Okay, so that is quite a nice result. So you can explore the model and see the result. But you can see one of the tricky part here is that are we really want to pursue the highest accuracy for each data? For example, here, if you look at the course tree, then it has only the number of 4 decision nodes, but it's already achieved an accuracy of 95.9. But when you do the ensemble tree, like a backlit tree, I will encourage you to explore this model. You will see there are many decision nodes. And for those many decision nodes, we only increased the accuracy from 95.9 to 96.5, which is very small increase. So I think it's very reasonable that we choose this simple model instead of this ensemble model, because in this simple model, we just only use a very few nodes to make a classification. And we always need to keep in mind that to make a medical AI model useful, you really need to keep it as simple as possible. You really don't want a very complex model and no one will use, because currently we still have no artificial intelligence that can work everything for you. The AI model, the value of AI model is to help us to do a very objective assessment. So that assessment should be very simple. So if in this case, I will choose this simple model, which has only 4 decision nodes here, but it can already achieve a very high accuracies. Okay, so I use these classification learners to give you a very simple tutorial, and I know 2 weeks later then we will do the case presentation 1, and in that homework we will try to classify the male and female gender just based on the cortical brain and brain volumes. So also the cortical thickness, etc. So I think you can not only try the regression model, but also you can also try the decision tree model here. And so I think that is you can try both and to evaluate the limitations and the advantage of each model. So I hope you enjoy this tutorial, and no worries on the case presentation one, because as I said, I think the purpose of this course is not only just do the lectures. Lectures is important, but I think the most important part is we will do some workshop, and so you can hands on the data and to develop your own ideas and on your own data. So I hope you enjoy this workshop, and we will see you next Thursday. Thank you very much.